Okay, hopefully this is a shorter video, but you can follow the longer version of it elsewhere. Okay, so the idea is this. The model of the atom had a history, has a history behind it, and I'm going to lay it out very quickly, I hope. So imagine that there was a guy called Thomas Dalton, and he stipulated that for reasons that we've already discussed, there are atoms, and these atoms can form chemicals if you bond them together. So water is H2O, for example. So you have one oxygen and two hydrogen atoms stuck together. Okay, so, and that never changes. That ratio never changes. If you take it apart, you get two hydrogens and one oxygen. If you stick it together, you have H2O, and they will only combine in this way. Now, that basically means that you've now got Lego bricks. But J.J. Thomson was a scientist who basically took a metal and heated it up. So what happened was, when he heated up a wire of metal, is that he could see something, a beam coming out of this. So he heated some metal up, and what came out of it was a beam of something. And he put that between plates, electric plates, positively charged and negatively charged plates. And what happened was the particle was attracted to the positive plate. That meant that the particle itself had to have a negative charge, and it was repelled by the negative plate. So this led to the discovery of the electron. It was negatively charged. It was a particle that was in the atom. So now that you've got the electrons in there, in the atoms, okay, so the electrons are somewhere in the atoms there, how are they held in the atom? If they are all negatively charged, they should disperse. They should just be repelled by one another. And so people thought, okay, well, there's a sort of vague positive charge in these atoms, and that is like butter is holding the plums in it, in a plum pudding. You are basically keeping the electrons in there. So then you got Rutherford, Marsden, and Geiger, and they did an experiment where they basically fired positively charged alpha particles at a target, and the target was a very thin foil of gold foil, gold leaf, and you can make that extremely thin. So they had alpha particles, and we'll talk about them later, but they're positively charged, and they were fired at that gold leaf. So the gold leaf is, of course, full of gold atoms. So if there's a sort of vague positive charge in there, and there's some negative charges, you'd expect the positive alpha particle to veer towards the electrons, and it's sort of, you know, be slightly deflected by the electrons, but essentially go through. The net effect is probably that it will go through pretty much in a straight line, or be deflected just very, very little. Okay, but what they actually found is that sometimes they looked at this on a screen, so they could see the little splashes of light on the phosphorescent screen as the alpha particles hit. Sometimes they actually found that some of the alpha particles were reflected right back at them, so almost through 180 degrees. And they looked at that and they went, well, if that's the case, then the alpha particle, the positively charged alpha particle, can't just be deflected mildly. There has to be something in the atom which deflects it quite a lot. And so this then meant that you had to have a positive center, or something hard and positive in the atom, which would allow the alpha particle to hit it and then be deflected almost back to the observer. Okay, so here's my alpha particle, and it gets deflected almost to 180 degrees. But this then led to the problem that you no longer have the butter basically keeping the electrons in that vague sort of confined to the atom. But here's a good thing, because Einstein already discovered that if you, and other scientists of course, that if you shine a light on some metal surfaces, you can ping out electrons, and it doesn't work for all wavelengths, so it doesn't work for all types of energy packets. Light, you can see light as a delivery mechanism for an amount of energy. So when you hit the metal surface with the correct amount of energy, you actually get an electron pinged out. That means that it is not any old light that can do that can move the electrons. Now, in an atom, what you find is that if you look at a spectrum, if you look at the entire spectrum of light, so if that's sunlight, and you shine it through a sample of hydrogen, you find that some of the light disappears. So you get black lines in that spectrum. So you still get like red, orange, green, and so on going through, but some of the spectrum disappears and it produces black lines. And that's because the electrons absorb some of the energy and go to a excited state. They go up a level. It's a bit like when you throw an orange up and then you throw it further up. You've given it more energy, and then eventually the orange comes back down. Let's say the electrons can't fall into the nucleus, of course. So it's more like if I sit at this table here, and the orange isn't allowed to fall right down to the earth, but it would fall onto the table. So I can pick up the orange and I can throw it up, and it has more energy briefly and then comes back down. And not only that, you can also look at the light being emitted by the hydrogen. So that's mainly black. Except for the exact same lines that we had before being given out as light. And that means that when the electron comes back, it gives out light. And that is only allowed for a certain set of these photons at a certain energy. And that's what Niels Bohr found. So he did some calculations, and he found that for hydrogen, at the very least, it was predictable. We now have a hard center of the atom, which is called a nucleus, and we know that protons are in it. James Chadwick later on found that there were such things as neutrons. You don't need to be too involved about how he found that, but essentially it gives you the entire description of atoms as we need to understand them. Of course, you've probably heard about quarks, but we are not bothered at GCSE level just yet. So the atom consists of positive charges in the middle called protons, then some neutral charges called neutrons. So these have no charge. And they're actually required as well to keep the nucleus together to some extent. And then you've got negative charges going in an orbit called a shell around the nucleus, and they are negatively charged. So the protons are holding the electrons in orbit around them, a bit like gravity does the planets around the sun. So I hope you found this useful, and I shall see you in the next video. Okay, so some rando on YouTube challenged me to teach people for free, so I'm doing that now. GCSE, A-level, chemistry, physics, whatever you like, let me know in the comments, like and subscribe. Thank you.